Hello class. So today we're going to go ahead and talk about solving exponential equations when functions have the same base and when they do not have the same base. so so we can begin today. Whoops. So we can go ahead and begin today. We're going to go ahead and notice that these do indeed have the same base of 3. So according to the rule, according to our property, that means we can take the exponents and set them equal to each other. So this exponent for this function right here is going to be 2x, and it is equal, since it has the same base, to this exponent, which is x minus 2. I can go ahead and combine like terms, subtract that x, I get x is equal to negative 2. Okay, and I can go ahead and check my work by substituting this negative 2 into here. So I got 3, 2, and what was that? Negative 2 is equal to the right hand side, and let's go ahead and double check that. 3 parentheses, my solution was a negative 2 and minus 2. Fudge, minus 2. So I got all of this right here, gives me 3 to the negative 4 is indeed equal to minus 2, that is negative 4. So it does check out. So let's go ahead and practice when they do not have the same base. So let's pretend these do not have the same base. So let me go ahead and give myself some space here and erase this. And let's pretend that I tried my best to get them to factor to be the same base or reduce them, but I couldn't. So what I'm going to go ahead and do is use my properties of logarithms, and notice that if I have an exponent in a natural log, let's go ahead and say I have a c exponent, I can go get ahead and use this exponent and bring it to the front. Now let's say we don't have an ln. Well, what I want you to know is that you can still introduce a logarithm. So let's go ahead and try that. So let me rewrite this. I'm going to go ahead and say ln of 3 raised to the exponent 2x is equal to the ln of 3 raised to the exponent x minus 2. Okay, according to this property, I can get the exponent and bring it to the front. I can get the exponent and bring it to the front as a coefficient, as my leading term. So I should have parentheses 2x, because it's together, ln of 3 equals parentheses x minus 2. Be very careful here, ln of 3, because these are together, guys. Okay, so let's go ahead and continue. This right here, if I go ahead and distribute, it stays the same. So it's going to be 2x ln of 3. But notice how I told you, you're going to distribute. So you're going to distribute this ln of 3 to the x. That gives me x ln of 3. Then you go ahead and distribute it to the inside over here. So that gives me a negative, because it's a subtraction of 2, ln of 3. Okay, now we're doing the same thing. We're going to go ahead and solve for x. So you need all the terms that include an x to be on the same side. Okay, so I have 2x ln of 3 minus x ln of 3 equals minus 2 ln of 3. The reason for that is because I went ahead and moved this x ln of 3 to the left hand side, so I must have subtracted. That's how I got this part right here. Okay, now from here I can go ahead and combine like terms. Notice that these two terms still include the x's. Whoops, still include the x's right here and right here. So if they both have x's, I can factor them out. So x equals what is left over of this term. If it has 2x ln of 3, if I factor out the x, I have 2 ln of 3 minus, let's try that one more time. I factored out an x from this entire thing, so I'm left with ln of 3 equals negative 2 ln of 3. Okay, let's see if I can go ahead and combine like terms. Give myself a little bit more space here. How do I do that? Interesting. Okay, so I'm going to go ahead and continue over here, and notice that I do have like terms right here. So I have 2 ln, so 2 apples minus 1 ln, so minus 1 apple. So I can combine that, so it's going to be x 2 apples minus 1 apple, that is just 1 ln of 3 equals negative 2 ln of 3. Now I'm solving for x, so I'm going to go ahead and divide by this, ln of 3, divide by ln of 3, so x is equal to negative 2 ln of 3 over ln of 3. Do you notice the like terms? Ln of 3, ln of 3, x is equal to negative 2. And that was the solution that we had at the previous one, when we did it by its properties only. Okay. Before we go into the next video, I'm going to go ahead and stop this one as its own. Thank you.